displacement, and average velocity. So let's take a look at the physics of one-dimensional motion. And the first thing we're going to study is displacement and average velocity. So what exactly is average velocity? Well, let's first take a look at this guy running a 100-meter sprint. So the starting point here is at 0 meters and the finish line here is at 100 meters. So the first thing we're going to do is to define a coordinate system. And since we're in one dimension, we only have one axis, let's say the x-axis, and let's define the x-axis to point along the sprinter's path. It's really up to us how we want to define the coordinate system, and in principle, we could define the coordinate system so that the x-axis is pointing to the left of the starting point, and in that case, the sprinter would be running in the minus x direction. So we can define the coordinate system how we want, but it's important to keep consistent. And so to keep things simple, we say that the sprinter is running in the positive x direction, so we define the x-axis to point to the right of the starting point. And a useful way to describe the motion of the sprinter is to look at the changes in his x-coordinate over a certain time interval. So let's say that 3 seconds after the run has started, the sprinter is at this point P1. So at the time T1, which is 3 seconds, he has reached P1, and let's say that P1 is 20 meters from the starting point. And let's say that 8 seconds after the run, he has now reached the point P2. So T2 is now going to be 8 seconds, and X2, let's say that it is 75 meters from the starting point. Well, then what is the displacement? Well, the displacement is a vector which points from P1 to P2, and the magnitude of this vector is going to be the change in the coordinates x2 and x1. So the displacement is going to be x2 minus x1, which is 75 meters, minus 20 meters, which is 55 meters. And how long did it take him to run from P1 to P2? Well, it took him T2 minus T1 seconds. So that's going to be 8 seconds minus 3 seconds, which is 5 seconds. So now we have everything we need to determine the average velocity. And the average velocity is a vector. So it has both a direction and a magnitude. And the direction of this velocity vector is going to be to the right of the starting point, since he is running along this path. So let's say VAV here is pointing in this direction. So what's the magnitude now of this average velocity vector? Well, that's going to be the displacement divided by the time interval that it took him to run from P1 to P2. So the magnitude of the average velocity is going to be x2 minus x1 divided by t2 minus t1, which is 55 meters divided by 5 seconds. Oh, we forgot the unit here. And that's going to be 11 meters per seconds. So that's really the speed that he is running from P1 to P2, or sorry, the average speed which he is running when he's running from P1 to P2. And when I say the word speed, well, then I'm talking about a scalar value or the magnitude of the average velocity vector. So the average speed that he's running from P1 to P2 is the magnitude of the average velocity vector, which is 11 meters per second. So in one dimension, we can say that the displacement is the change in the x-coordinate, and that the average velocity is the displacement divided by the time interval that it took him to run this displacement. And one last thing I will mention is that it's useful to write this term here as delta x. So it's useful to write the displacement as delta x, and it's useful to write the time interval as delta t. So we don't always have to write x2 minus x1 or t2 minus t1. We can just write delta x and delta t. So the term delta here is really a change between 2 points.